You're welcome back to my YouTube channel. And in this particular video, we're going to be talking about the last one on the list here, which is the differentials. Now, in exact differentials are of the form m dx plus m dy equals to 0. But even though that is not um, the only thing that makes it an exact differential, what you can use to confirm if it is an exact differential is if the differentiation of m with respect to y, the partial differentiation of m with respect to y is equal to the partial differentiation of n with respect to x. And we have an equation in our hands today that we can use to practice that verdict, which is this over here. So now we have 5x power 4 plus 3x square y square minus 2xy cubed dx plus 2x cubed y minus 3x square y square minus 5y raised to power 4 dy. Now you notice this is with respect to the x and this is with respect to the y. So from this here, you know that this is our m and this is our y. So for us to confirm if this is an exact differential, we have to check for this and check for this. As we differentiate m with respect to y. So now, if we differentiate with respect to y, like if we differentiate this will give us 0. This here will give us plus 6x squared y, yeah, plus 6x squared y, and this here is going to give us minus 6x y squared. That is on differentials for this. So let's remove this cell out here. And if we differentiate n with respect to x, which is this here, if we differentiate n with respect to x, we have 6x squared y. Here would be minus 6xy squared, and here would be minus 0. So let us just ignore it. So now you notice that yes, this here is equals to this right here. So that means this is an exact differential. Now what do we do when we notice that this is an exact differential? And that is what it is here. We integrate m with respect to x and integrate n with respect to y, but at that n with respect to y, every value of x there must be equals to 0. That is, we integrate this value right here of with respect to x, but when we reach here, anywhere we see x, anywhere we see x, we put 0. So that is what we are going to do. So now, in order to solve this, we put our integral sign. We integrate 5x raised to power 4 plus 3x squared y squared minus 2xy cube dx. So now that is for this. Why in this particular case we have plus the integration of, now every value for x here must be equal to 0. So we are going to be having 2 times 0 cube y, and we know anything multiplied by 0 is equal to 0. So that means that one wipes out. So that means naturally you see that wherever you see x, you cancel it out. There is x here, x will be equal to 0. It cancels out. So here we are going to be having minus 5y raised to power 4 dy, which is the only y value that is left here. So if we integrate this with respect to x, we are going to be having 5x raised to power 5 divided by 5, so that 5 cancels 5 here, and here we're going to be having plus, if we integrate with respect to x, we are going to be having 3x cube y square over 3. That is this 3 here, so the 3 cancels 3 here, and also we have minus 2x square over 2, and we have our y cube over here. So these two cancels 2 naturally, and the one in here we have our minus common side here, and we have 5y raised to power 5 divided by 5. So the 5 cancels the 1 here, and our final answer here is going to be equal to, let's not forget our equals to 0 there, equals to 0. Our final answer here is going to be x raised to power 5 plus x cube y square minus x square y cube minus y to the power 5 is equals to 0. So now this is our final answer, and that is how to solve an exact differential. So now in our next video, we are going to be talking about equation that can be reduced to homogeneous functions, equation that can be reduced to linear equations, and equation that can be reduced to exact differentials and stuff like that, because not all the time that it will come as the perfect form that you actually want it to be. Thank you very much.